Hey everyone, welcome to our chapter 2, which is the Introduction to Chemistry, and our lab 2, which is Measurements and Equipment Lab Recap. So, again, this is just designed as a short little quick hit, seeing that multiple instructors are making your full length lecture videos. This is sort of that very quick, what do I need to know to be successful in getting started? So let's do that. First off, this chapter starts with what is matter, and matter is anything that has mass and takes up space. So guess what? You matter. Da-dun. It exists in three states: solid, liquid, and gas. And again, all living things are made of matter. And these, of course, are our chemistry properties, but they are important as we are working in biology to note those chemical laws that are going to govern how these molecules interact and sort of shape that biology. Of course, we have some common elements that make up the living world, and I like to call it CHNOMPS. That's carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Then, of course, we come over here to our structure of atoms. Our atoms are going to have a nucleus where we have our positively charged protons, our neutrally charged neutrons, or no charge, and then outside of that nucleus in our orbitals or our electron shells, those are going to be the electrons, which are negatively charged. All right. In order to calculate these subatomic particles, we are going to look at the periodic table of elements, and we're going to see something that looks an awful lot like this box over here. And we know that the atomic number is the number of protons. Number of protons is also the number of electrons. And then the mass, which is this number here at the bottom, that is going to be the protons plus the neutrons. So we subtract the atomic number from the atomic mass, and we're able to get the number of neutrons. Then, in order to figure out where our electrons, which is also matching this atomic number, we want to figure out where they are. They fill up the electron shells. The first shell is going to hold 2 or up to 2. Then every shell outside of that can hold up to 8. And the very last shell is called our valence electron shell. If you are hoping to earn some bonus points like you did for chapter 1, then use this oxygen and give me the number of protons, electrons, neutrons, and then how those electrons are organized. So you can say shell 1, how many are in there? Shell 2, shell 3, shell 4, shell 5 if we go that high. I don't want to give too much away, and that will get you some bonus points on your quiz. Oh, we went backwards. We want to go forwards. Okay. We also have in this chapter the idea of isotopes. Isotopes have a different number of neutrons, but the same protons and electrons. They are radioactive, and this chapter also talks about Fukushima and Chernobyl, showing the effects of that radioactivity, nuclear disasters that occurred in those places. We then move on forward to the types of bonds. We have ionic bonds where we are going to give away or take on an electron. If we give an electron away, that atom becomes more positive and we call it a cation. Think of that T in cat like a big plus sign to tell us it's positive. If we take an electron, then we are a negative ion or an anion, and that is going to be our negative one. and then they're attracted to each other because of those charges. Then we have covalent bonds. We first have non-polar covalent bonds, meaning my atoms are about the same size and they equally share those uh, electrons with each other. And we can have our single bond where we share one pair, double bond where we share two pair, or triple bond where we share three pairs. Then we've got polar covalent. A great example is water down here, where one atom is really big and electronegative. We have then a bond to a much smaller, less electronegative atom, so we do not share those electrons equally. And in our example of water, oxygen is going to hold those electrons to it more often and become just a tiny bit negative. And here we have our hydrogen then not seeing those electrons and being just a tiny bit positive. And then those unequal sharing in a polar covalent bond could lead to something called a hydrogen bond, where this little bitty hydrogen is attracted to another oxygen in our water molecule, and then that oxygen is attracted to more hydrogens, and we make this weak interaction that becomes collectively strong, and we call that a hydrogen bond. Then, of course, we've got our properties of water that come sort of next in our chapter, which include cohesion. Water will stick to other water molecules. Adhesion, water can stick to other stuff. We have high specific heat, meaning it takes a lot of heat to change the temperature of water, even 1 degree. We have a high heat of vaporization, meaning it takes a lot of energy to make our water go from a liquid to a gas. Water has a surface tension, or again, it's attracted more to itself than to the outside area, meaning that things like water bugs can stride along the top surface. Water is also our universal solvent. Lots of things, anything that is polar or ionic, can dissolve into it. And then ice floats because of those hydrogen bonds that keep those water molecules sort of a arm's length apart from each other and allows ice to float. And then, of course, we have our pH scale. Anytime we mix things into water, we make a solution and we can measure its pH. That is going to be the measurement of the amount of hydrogen that is in that solution. If we have a lot of hydrogen, we are acidic and it measures on our pH scale 0 to 6. If we are not having too much hydrogen, we're taking it away or we're getting more hydroxide, OH, then we are going to measure 8 to 14, with 14 being our strong base. And then, of course, 7 is pure water that is neutral. We can do a neutralization reaction where we take an acid, mix it with a base, but we would never do that in real life because they can be quite explosive as we are rushing away from alkaline and acidic to that neutral. And then, of course, a buffer is a substance that resists pH change. Think of like an antacid tablet like Tums. You've got heartburn because of your stomach acid. You take that Tums. And then if you eat something like tomato sauce in spaghetti sauce or on pizza, it will prevent your stomach acid from becoming more acidic and giving you that heartburn and stomach ache. Then, of course, in lab this time, we're going to be looking at our SI units. In order to measure mass, we are going to use grams, length is meters, volume is liters, and temperature is degrees Celsius. Everything except degrees Celsius can be converted using our little jumpy ladder method. I like King Henry doesn't usually drink chocolate milk, or maybe you like this ladder where they're telling you to go from meters to centimeters to move the decimal points 2 places to the right, or if you're going meters to kilometers, you're going to move that decimal point 3 to the left in order to convert those units. That being said, if you've taken a science class before and you are used to using the cross multiplication or division, you use exponents, you absolutely can continue to do that. But this converting this decimals with our ladder method is sort of the entry level way in which to do this. That being said, our degrees Celsius takes a different conversion factor. It's a whole formula. I will not be testing you on doing that conversion by hand because we've got 9/5 or 1.8 and it's messy, but just knowing that that conversion does exist if you are excited about it. I like to use just the little saying 30 is hot, 20 is nice, 10 is cold, 0 is ice. For when I just want to look at a thermometer and I say, oh, it's 26 degrees Celsius. Well, that's close to 30. 30 is hot. I know that I need to wear shorts and a tank top. Meanwhile, if it's like 3 degrees, I know, okay, that's close to ice. It's going to be cold. I need to wear a winter coat. And that would work perfectly for our class. Then the very last part of this lab this week is knowing some common lab tools like an Erlenmeyer flask, a triple beam balance, test tubes, graduated cylinder, thermometers, pipettes and pipette pumps, and these little clip arts will come back to you in those quizzes in the future because, of course, you are not having these at your home for an online class. So these are the ones that we hope that you become familiar with even in those virtual labs. So if you are trying to think, what can I do? What should I do for the rest of this week and into the weekend? If you're following our schedule, Chapter 2 and Lab 2 notes, you can even begin that Chapter 2 Smart Book and the McGraw-Hill modules. I like to say Friday, Saturday, and Sunday are a great time to catch up on notes, catch up on assignments, study, and even take that lecture and lab quiz 1. But see, we've got these nice 3 days of catch up for Chapter 1, Chapter 2, Lab 1, Lab 2. And of course, please make sure you don't overwhelm yourself. Make sure you get a break and do something fun in there as well. And then, of course, we come back on Monday, and if you had not completed those quizzes, those are due on Tuesday, and start preparing for Chapter 3 and 4 and Lab 3 and 4, and we'll have another video for you when we get there. I hope that you are finding these helpful. Please let me know if there's anything else that you need from me, which of course leads me to ways you can get a hold of me. Obviously, I have my Trident Tech email. That's my preferred method. My social media is TTC Professor Merck there for you, and my phone number, which apparently I didn't type in, or maybe it's in invisible letters, but let me get that for you. It is, if you'd like to call my office phone and leave a number, you can give me a call at 843 574 6268. And if you leave me a message, I am happy to get back to you. All right, everyone, we will end this video here, and I look forward to seeing you next time.